You
that,
you look very handsome. Look like
oh,
Richard Gere. Richard Gere.
I didn't know what to wear, so I thought, well, I'll just wear this and that should be okay.
Yeah. So are you did you go to the last year IAO conference last year, sir?
No, I had been doing some other traveling, and I
Oh,
was in Los Angeles and
I see.
Hawaii, and so it just kind of fell at a unfortunate time, and
Uh,
I had been doing enough traveling, so I just wanted
yeah.
to. Uh, I wasn't able to go this year, but I did go the year before, and I'm thinking about going in Denver. It sounds like a good
Uh,
conference.
uh, Very good. After 20 years of membership, now I do not have much to go there, but still active in the valuation, but still not much to do with the IAO. But this is still a great organization for me.
Oh yeah, they've been so good to me. I've been a member for over 30 years now,
Oh
and
yeah, you are board member also. Mm.
yeah, so some of my best friends are from IAAO, and
Uh,
something that I'm so glad that I did when I was younger, because then I could learn things and meet people, and it just helped in so many ways. Then I got to meet you, so and I get this opportunity now, so I'm
Thank you, sir.
happy.
I remember
Uh,
I voted for you also in the past.
okay. um,
Maybe you can consider to run again sometimes.
oh, I don't know. I've been so busy with teaching and things,
Yes,
and
indeed.
there's a lot of opportunities now. Now that I'm retired, I think I'm busier than before I retired. So, but I got my own business and I'm teaching IAAL classes and I'm teaching at a college part-time.
Yes,
And
yeah, you
and
are
I'm
like
enjoying my family, going for walks and seeing some of the country and enjoying, the outdoors a little bit.
mm. Last time we have a class in Uganda, but our speakers from IAO could not make it. Uh, Unfortunately, maybe uh, in the future, maybe I can invite you to teach for us again.
Well, this would be a better time. I remember years ago you had
Uh,
asked, and I was still working for the city of Milwaukee, and
oh,
that was a problem. But now I don't have to ask permission to go somewhere.
uh-huh, yeah,
I got to ask my wife.
yeah, definitely.
But yeah, certainly if I can serve you anywhere, I'd be happy to do that. So.
Or
Um,
maybe come to Thailand too, like we discussed, if possible, because you may take maybe 2 or 3 weeks here, maybe just teach for a week or less, but you should traveling, roaming around, like Angkor Wat in Cambodia, world wonder, one of the world wonder, and also in Phuket, Samui, Pattaya, in our uh, sea beach and mountain area in Thailand and Myanmar nearby. So you may be, no,
uh-huh.
not Myanmar right now. Myanmar, they may be fighting. Maybe Cambodia, Vietnam, Thailand, Laos should be good enough to go for 2, 3 weeks with your madam.
Yeah, well, keep me in mind, and
Yeah.
certainly if things work out in looking at the schedule and things like that, we can talk about that.
Yes, sir.
I have a question for you.
Yes, sir.
So I need permission to share my screen. So I
Oh,
think somebody else has to click something on your end so that I can do that.
okay. So now we can uh, do some share screen now. So we will start in a few minutes. One moment, sir.
Sure.
I could make it like this. Okay, it should be better.
I think things are looking pretty good.
Yes, sir. So for the time being, so let me just start for a while so that we will have more time for you to speak. So let me welcome all our colleagues who are mainly valuers and real estate professionals into this Zoom. This webinar is done by our FIABCI World Council of Experts. FIABCI is the World Federation of Real Estate. In the US, there is also the National Association of Realtors, NAR, Appraisal Institute, and some others are our members as well. Hopefully, in the future, maybe the International Association of Assessing Officers and ASA, American Society of Appraisal, or someone else who joining us. But this FIABCI consists of brokers, valuers, property managers, architects, and definitely developers, investors. So this is a diversity of professionals in real estate. And the headquarters is now in Paris, in France, and established for over 70 years. So this is our FIABCI. And FIABCI, we have a lot of councils. I'm the president of Council of Experts. There are Council of Valuers, Council of Property Managers, Council of Practics, and something else. So our FIABCI Council of Experts organize these webinars. Last year we organized every month, almost every month, and this year we also trying to organize it very every month or as many as possible. But in January, maybe that is the hectic month, so we did not organize anything. And December, I remember that in December last year, I invited another lady from IAO. Her name is Madam Daniel, Lisa Daniel. Lisa Daniel. She was with the IAO as well to speak about valuing personal properties. So this is also something very interesting as well. So our FIABCI, if you like to be our member, you can contact the FIABCI headquarters or FIABCI chapters in different countries. I myself am also the president of the FIABCI Thailand. In Thailand, we have a FIABCI chapter. I'm the president and also other members like the Thai Appraisal and Estate Agent Foundations, Thai Real Estate Broker Associations, and Asian Urban Institute something. Yeah. So we have 3 principal members and also local Thai developers and professionals in real estate. So this is in Thailand. In India, they also have very big FIABCI, and many of the FIABCI presidents are property developers, maybe because they are affluent. Like the world president of FIABCI is now Mr. Budiasa. He is one of the largest developers in Indonesia. So very influential and very contribute a lot to our FIABCI community. And the largest developer in Malaysia, in the Philippines, in Taiwan, they are also our leaders in FIABCI. But in Thailand, I myself is a valuers, researchers, not developers. But we have many developers as our members as well. Okay, so today we will discuss about the mass appraisal. How to do a mass appraisal modeling. How to do a mass appraisal modeling. when I study English, when I was young, my American teacher said it should be called Mado. But my English teacher said it is model. So it is depend on different pronunciation. But mass appraisal is very interesting, and we have a great speaker today. But for myself, I learned a bit about mass appraisal back in 1990 by a professor from Lincoln Institute of Land Policy, based in Boston, Massachusetts. And our professors came to teach us in Taiwan, Taiwan, Taipei. So we went there to study, but the professors came from Lincoln Institute of Land Policy. Professor Dr. Cook, Dr. Cook, I still remember his name, Chansey Cook. So he taught us a lot about the property appraisal by mass appraisal back in 1989. And then in 1990, I started this modeling in Thailand. But at that time, we used just simple Excel to do that, and also with the SPSS to do that. So this is the starting in Thailand. Our mass appraisal is for property tax, and also for land readjustment or land pooling, and also for desktop valuation for banks, for financial institutions. Okay, so that is our familiarity with mass appraisal. But today we have our speaker, that is Mr. Scott T Winter, CAE. This is a title for the International Association of Assessing Officers. So it is an honor for us to have Mr. Winter. Good morning, good evening to you, Mr. Winter. So it should be 8 o'clock in Milwaukee, in your city, in the US, in Central Time, right? It is 8 o'clock.
Yes.
But it is in the evening. But in Thailand, it is 9 o'clock. But at this moment, our colleagues from Saudi Arabia said it is around 5 o'clock in Saudi Arabia, in Iraq, Iran, in Ukraine. We have a lot of members there as well. Maybe it is 2 o'clock in the morning. So they could not join us. But we have a record and we try to put it in YouTube. So in a day or two, your presentation will be distributed to our member as well. So maybe some of our members may like to learn from you. And we organize it at this time in Bangkok, 9 o'clock. In the Philippines, it is 10 o'clock. In Indonesia, also 9 o'clock. Vietnam, also 9 o'clock. In Malaysia, 10 o'clock. And these countries, they really like to learn from you, because maybe we can invite you to come to teach us here or to demonstrate some projects here. In Myanmar, we also have our colleagues from Myanmar, from Laos. From Myanmar, it is now around 8:30. But in Laos, Thailand, Vietnam, Indonesia, these countries are now 9 o'clock, like in Bangkok. So I think this country should learn a lot from you, and we can have you as our resource person. This matters. So before Mr. Winter start, allow me to introduce Mr. Scott Winter a bit. Mr. Winter, as you may know, that he spent over 18 years, 70 years as a assessment division manager in the city of Milwaukee. Very good city. And hold a bachelor degree in business administration in real estate from University of Washington. Wisconsin, Milwaukee. And he earned also a CAE, that is a title, an IES designation from the International Association of Assessing Officers, where I was a member for over 70 years. And he is also a certified appraisers and adjunct professors, now adjunct professors in Waukesha County College. and he is also a certified USPEP instructor. USPEP is the uniform standard for professional appraisal or something, practice for the US by the Appraisal Foundation. And he is also speaking for the IAAO and Wisconsin Association Assessor and also some other. So these are what about our speakers on mass appraisal. And he has been also the executive board of International Association of Assessor in the past as well. So this is our briefing something about our speaker for today, Mr. Scott G Winter. So you can realize that my speakers, my great friend, is very formal and very polite. And as I told you, in my mind, he looked like my favorite movie star, Mr. Richard Gere. Okay, so Mr. Winter, maybe you can kindly start, and we may spend say an hour or less, and then maybe have a Q&A session. So let us welcome Mr. Scott Winter, please.
Well, thank you very much, Sopon. My wife and I just got back from Honolulu, Hawaii, and there's a 4-hour time difference. And before that, we were in California, and then we were in Florida, which is 2 hours the other way. So when it comes to knowing what time it is, it's more of a challenge lately than it has been in a while. So I can appreciate the different students being here in different time zones, and for wherever you are and whatever time zone it is, I thank you for being here, and it's my honor to serve you as best I can. I teach a lot of IAAO classes. I have my own business now, and I teach many different classes, and I write classes for a college here in Wisconsin and teach there not only property assessment classes, but property appraisal classes too, for real estate appraisers that do one property at a time. And I've been in the business for over 30 years and have been doing a lot of teaching online right now. And it's just becoming a greater opportunity to serve more people. So thank you for having me. I'm here because of my friend, Dr. Sopon, and here's a picture of him and Mr. Larry Clark, where we had seen each other at another IAAO annual conference, and over the years,
thank you, sir. Thank you.
Together, and I can tell you that Dr. Sopon is highly regarded at IAAO, and we are so fortunate to have him as a speaker and an influence for us, and I'm sure that you appreciate him as well. So thank you, Sopon, my good friend, and I'm going to talk about mass appraisal. I just got done teaching a 30-hour class on mass appraisal, so and just barely scratched the surface of the topic in 30 hours. So in a class of an hour, I can't cover everything that I need to cover. However, I can introduce you to the concept of mass appraisal and maybe point you in some directions that could help you learn more. I've been teaching mass appraisal for many, many years, and I still am learning new things. And one of the things that I like about being an assessor and being an appraiser is it fits into my world philosophy, is that I'm always able to learn something new. And when I teach classes, I learn things from the students. And so, as Sopon mentioned earlier, when I'm done with my presentation, if there's some time, we could have some questions and answers, and you can share different ideas that you have or different questions that you have, and I can try to answer them. So with that, we'll get into the material. And we're going to focus on mass appraisal. Mass appraisal is different than looking at one property at a time. That's how I learn appraisal, is one property at a time. But then I got a job for the city of Milwaukee in Wisconsin in the USA, and we've got 160,000 parcels that we had to put a new value on every year. And we had about 60 people, about 30 of which were appraisers. So for 30 appraisers to do 160,000 appraisals every year can't be done. It's too much to do one at a time. So what we do is incorporate mass appraisal, and that's in our assessment office. Now, mass appraisal is used by assessors all over the world, but mass appraisal is also used by banks, by Zillow. You might have heard of a company called Zillow. There's other applications in the financial world where people use mass appraisal, where by definition, it's a systematic appraisal of groups of properties as of a given date using standardized procedures and statistical testing. I underline a few of the words here because I wanted to point out their importance in the definition. It's a systematic appraisal. As assessors, we need to be fair and equitable. The property tax is based on the assessments that we come up with through our formulas. And so it has to be systematic. Sometimes I would get a phone call after we do what we call a revaluation, where we change all the assessments, do a reappraisal of every property. And so then people call up that own the properties and say, well, my neighbor's house is the same as mine, but my house is assessed for more than my neighbor's house. Why is that? That does not seem fair. Well, I could look at the record and say, well, your house has a garage and your neighbor's house does not have a garage. They are both the same property. However, you have something that your neighbor does not have, therefore it is worth more. It's systematic. And so every property that has a garage would have some value added, and every property that doesn't have a garage would not have that amount of money added or value added. Same thing with air conditioning and other attributes. So it's a systematic appraisal where it can be done by pushing a button on the computer, and it systematically reappraises all of the properties based on a mathematical model. Now, we also use humans as appraisers to check that. And there's never been an instance where we've pushed a button to do an appraisal for mass appraisal where we did not have human beings also look at it and make adjustments and what we call calibrating the model. So we have to set up a model. It's called model stratification, and then we calibrate the model calibration, where we tweak it, and maybe we're saying, well, we're adding $25,000 for a garage, but that's a little bit too much. How about if we added $15,000 for the garage? Oh, that's not enough. How about $20,000 for the garage? And so we calibrate it. We systematically appraise all the groups of properties such as residential groups. And even within the residential groups, there might be residential homes on the north side of the jurisdiction and residential homes on the south side of the jurisdiction. Or groups of properties might be condominiums or retail stores or warehouses or hotels, office buildings. So we can take all these different groups of properties and stratify them into a group of similar properties and then do a systematic appraisal on that group of properties as of a given date. Now, many jurisdictions, when we do an assessment, we have what's called the effective date or statutory date. An effective date is the same concept as any kind of appraisal. That appraisal is good for one day. The next day, something could happen that would change the value of the whole jurisdiction or of that particular market. So when we come up with an assessment, when we come up with an appraisal of a systematic group of properties, it's as a given date. It's using standardized procedures so that everybody gets treated in a fair manner. And then we've got statistical testing at the end to see how our mathematical model did, how our mass appraisal model did. And we can test that by different mathematical procedures to find out if we are close in our predictions, what the margin of error is. Are we very confident in these assessments? Are we not so confident? And I'll talk a little bit more about that statistical testing in a little while. But assessors use mathematical modeling to do this. When I talk about a model, there are basically three kinds of models that we can use. There's an additive model, there's a multiplicative model, and there's a hybrid model. There's three different types of models that can be used depending on the kind of property and depending on the situation. The first one I wanted to talk about was what we call an additive model, and it looks something like this. We've got V, which is your value, your market value, plus B sub O. So when you see something that looks like this, B with a little O, the right way to say it is B sub O plus B. Hold on, please. On the bottom left of your computer, there's a little red microphone, and that should be on. And that way, if there's any noise in the background, then we won't hear any kind of background noise. And so if you could please keep that on. Anyways, looking at the model here, we've got the B sub O, which is what we call a constant. Then we've got a B sub 1 times X sub 1 plus B sub 2 times X sub 2 plus B sub 3 times X sub 3. The little asterisk is in place of a multiply sign in this case. And we can have various parentheses in order to create this mathematical model. Now, notice it looks like an equation, right? And that's exactly what it is. It's a mathematical equation. The X's are the property features. So the first X might be size, the next X might be land value. The B's are dollar rates or amounts. So if I have a house that's 1,000 square feet is the size, that's the property feature, which would be my X. That's 1,000 square feet. And the B, if it's $120 a square foot, would put 120 into that. This B sub O is the constant. That's a concept that is a starting point. As an appraiser, you're looking at your group of properties and your assignment. As an appraiser, there's always a little bit of math and there's always a little bit of art. You have to look at the situation and what you have and decide what kind of model do I want, what are the central points of my model, and that's where that constant amount comes in. Now, I used to appraise condominiums in the city of Milwaukee. I did all the condos, and sometimes you've got a high-rise condominium, and we're right next to Lake Michigan, and we would have 20 stories high, and excuse me, on the first floor would be worth less than the second floor, which is worth less than the third floor. The higher up you go, the better view you have and the more it's worth. Some properties have garages, some condo units have garage space, and some don't have garage space. Some have a view of the lake and some don't have a view of the lake. So when I have this condominium tower, this big high rise is 25 stories, to get my B sub O, my constant, I would look at the unit on the first floor. That's the smallest one that does not have parking, that does not have a lake view. And if that's $50,000, and if I have $2,000 per floor, if I have a similar unit, not on the first floor, but on the second floor, I add 2,000. If it's on the third floor, I add 4,000. And so I'm adding to this starting point, this B sub O, this constant dollar amount. That's just one example of how that works. And when we use mathematical software, that B sub O, that constant value, can change, but it's always like the starting point that we would add other attributes and value to. So for instance, I've got my market value equals my B sub O, which is my constant, plus B sub 1 times X sub 1. Now, if the B sub O in my case is $50,000, that's my most common unit, that is the most plain. And if my square footage is my variable, $120 is my coefficient, I would simply take this formula and insert the numbers. So if I've got B sub 1 is 120, I put that here. If I've got my square footage, I put that here. And so now I've got B sub O plus, in parentheses, 120 times the square footage. Well, what if my square footage is 1,000 square feet? Okay, so if my square footage is 1,000 square feet, now it's 120 times 1,000 plus my constant. If my constant is 50,000, it's 50,000 plus 120,000, and my value would be 170,000. So this is a very simple way of showing you this idea of an additive model. Now, if I have something like B sub 1 times X sub 1, that is called a term. The variable is the X and the coefficient is the B. The coefficient is the $120. And so I might have to calibrate that. 120, 115, 125. I can do that through my statistical testing. But the terminology is important. The B is the coefficient, the X is the variable, and the constant is that B sub O. So any questions on that? All right. Here's another example where here's my constant and my rate of 50, my square footage of 1,000, and I've got a land rate and a land size and a rate for central air conditioning, and I've got one central air conditioner. So if I have a mathematical model, I would have my model look something like this: B sub O plus my rate for the building times the square footage plus my rate for the land plus the lot size plus my rate for central air times however many central air conditioners I have. So I plug in 40,000 here for my constant. 50 times 1,000, that's the 1,000 square feet for the building and $50 a square foot. My lot size is 2,000 square feet, and I got $15 as my rate. And my rate for central air is 5,000. I've got one of those. So I simply plug the numbers in, and I got 40,000 times 50,000 times 1,000. That's the building. Times 15 times 2,000 is the land, plus the air conditioner. So it winds up being 40,000 plus 50,000 plus 30,000 plus 5,000, and my market value for this property is $125,000. Now, if I did not have air conditioning in a different property, I would say 0 air conditioners. Well, what's 5,000 times 0? That's 0. And so I would add 0, and then I would have simply 50,000, 40,000 plus 50 plus 30, and I wouldn't add that 5,000 in there. A multiplicative model is another type of model, and a lot of times we use that for rates. For neighborhood, different neighborhoods might have different neighborhood factors, or there might be a rate for a commercial property for the market rent. And so if market value equals, again, I've got my base rate, and then the F are the adjustment factors. So if I've got market value equals my base times the square footage times something like percent good. Percent good is the opposite of depreciation. It always has to equal 100%. So if I've got something that's 20% depreciated, it's 80% good. If I've got something that's 30% depreciated, it's 70% good, etc. Heat and air conditioning and a neighborhood factor. So if the R sub O is $30 and I've got 1,000 square feet, that would be my market value equals $30 times 1,000. And here's my factors. For my percent good, this one here is 80%. So I got 0.80 times 1 times 1.05, and my market value is 25,200. That would be a mathematical model. If I have another property and the percent good is 75, well, then I just exchange 75 in here. If I have another neighborhood and the factor is 1.08, I just put that in the formula, in the equation, and it systematically then calculates a value for every property. A hybrid model is similar. It's a combination of the multiplicative and the additive. So I've got multiplying in between the parentheses. So I've got the price of improvements times the quantity of improvements, price of the land times the quantity of the land, plus my other additions that might come onto land, like a garage or a gazebo or a shed. This GQ is what we call a general qualitative factor, which is a neighborhood factor. So I might have a similar property in neighborhood A, and my general qualitative factor is multiply that by 1.05. I might have a different neighborhood that I multiply by 1.08 or by 1.12. And so the general qualitative factor is basically a neighborhood factor. This is a common model type for the cost approach. Here would be an example where I've got, again, an equation where I've got the neighborhood factor times the rate times the square footage and the rate of the land, lot size, and added items. And just kind of looking down, if these are the rates for the land and the lot size and the added items, and I would simply plug these in. The general qualitative factor, that neighborhood factor, is 1.05 times, in here, 50 times 1,500. Okay, that's my building size, 50 times 1,500. Here's my lot size, $5 per square foot, 20,000 square feet, plus 5,000 for additional items, and the number would come up to 180. So this particular property would be assessed at 180,000. Now, when I look at the variables, remember I looked at the variable for the additive model. I had my B and my X. The X was the variable. There we go. The X was the variable. The B was the coefficient. What are variables? Now, I could have a variable for square footage, like we saw. We could have a variable for effective age. a variable for bathroom rating, for percent good, for fireplace, and another variable for garage. We're just making a longer equation. Central air, rec room, wood deck, lot size, kitchen rating, neighborhood, view, condition, grade are all variables that if they're important, we can add to our model. There's different types of variables. In our model, we have what's called a binary variable, which is simply yes or no. It's either there or it's not. Does it have a swimming pool? Yes or no. So if I have a binary variable, I'm going to look at how much a swimming pool would contribute and say it's $10,000. And I would multiply that by 0 or 1, depending on if it's there or not. If that particular property has a swimming pool, I would multiply it by 1. If it doesn't have a swimming pool, I multiply it by 0, and it doesn't contribute to anything. Binary variable could be, does it have central air? Yes or no. Does it have a swimming pool? Yes or no. Fireplace? Yes or no. Is it on a corner lot? Yes or no. Is it in neighborhood A? Yes or no. Is it in neighborhood B? Yes or no. So if it's in neighborhood A, it cannot be in neighborhood B. Now, if in my string, in my equation, I've got central air times 0 or central air times 1. So if my central air contributes $5,000 in my equation, if it doesn't have it, I just multiply it by 0 and nothing gets added. If it does have one, then I add $5,000 to my string of equation. Another example, if it's in neighborhood A, it cannot be in neighborhood B. And so if it's neighborhood A contributes $20,000 and neighborhood B contributes $30,000, how does that look in the equation? Well, it would be either 20,000 times 0 or 20,000 times 1 plus 30,000 times 0 or 30,000 times 1. It can only be one of each of these, right? If it's in neighborhood A, then that would be a 1 and that would be a 0. If it's in neighborhood B, that would be a 0 and that would be a 1. I also have what they call additive scalar variables that are important when it comes to maybe like a quality rating, like a bathroom quality rating or a kitchen quality rating. And so I could say, well, if average is, I'm not going to add anything for average. If it's good, I'm going to add $3 a square foot. If it's excellent, I'm going to add $3.50 a square foot. If it's poor, I'm going to only add $2 and very poor $1.50. I would have my factors here. So looking at what we call a scalar variable, if I've got a rating of excellent, good, average, poor, very poor, and I have $2.50 is my amount for an average kitchen, let's just say a kitchen, for example, that would be my constant. That would be my my starting point, my central point. And I can come up with a factor to multiply any property by taking the amount per square foot and dividing it by that 250 that I get from the average. So if it's average, I divide 250 by 250, and that is 1.0. I don't have to, I multiply something by 1 and it doesn't change. If it was good and $3, I divide the $3 by 250. I get that from the average, and I have a factor of 1.2. If it's excellent, I divide 350 by 250, I got 1.4. If it's $2 divided by 250, I got 0.8. And if it's very poor, it's $1.50. I divide it by 250 and it's 0.60. So what I can do in my mathematical model, if it's in poor condition, I multiply it by 0.8 and that brings the value down. If it's in very poor condition, say it's $10,000, I multiply it by 0.6 and it brings it down even farther. If it's in good condition, I multiply it by 1.2 and it brings it up 20%. If it's excellent, I multiply it by 1.4. And so when I have things like these scalar variables, let's look at like the excellent, good, average, poor, very poor. And if you notice, if it was excellent, only one of these parentheses is multiplied by 1, right? So in my long string, and I've got other terms in my equation, garage, size, condition, everything else, but for kitchen rating, if it's excellent, I got 1 times 1.4. And then everything else is a 0 times this, 0 times 0 times, so the only thing that gets contributed is the 1.4. If it was good, then that is a 0 and that becomes a 1. Where did I get that from? Well, from here, the 1.4 to 1.2, I can only have one of those at a time. And so this one would be 1 and all the rest would be 0. If it's average, this is 1 and all the rest are 0. If it's poor, that's 1. I multiply it by 0.8, and if it's very poor, by 0.6. And that is calculated in my long string of equation. That equation that I have forms a line. That line is the predicted value for what we call the independent variable. So I have a tool called a scatter diagram. And for every sale that I have, I can look at the size and I can look at the assessment ratio. If my assessment ratio is 1, that means that my assessment is right how I predicted it. But every dot here is a sale, an actual sale price represented by my market. This line here is actually something that I can generate from the computer that gives me a prediction of something within the center of all those sales. And that line gets drawn to reduce the distance between the line and the dots. The line is my prediction of what the value would be. So if I'm at 2,500 square feet, and if I go up to the line and I run across here, that would be the value. If it's up here at 500 square feet, it would be a ratio up in here. It's just a prediction. And so I can draw that line to predict it so that I have the least amount of distance between as many dots as possible. Every dot has a distance between the dot and the line. And so I want to reduce that distance either on the top side or on the bottom side by drawing that line. Now, if I have an Excel spreadsheet, and I'm assuming you can see that, right? Okay, are you seeing something that shows some assessments and sale prices?
Yes, I do in the Excel.
Okay, so these are the assessments and the sale prices. And I can come up with a ratio. I divide the assessment by the sale price to come up with this number. And if I want to put these in a scatter diagram, in Excel, I can just put insert. And then over here, there's a little icon for scatter diagram. Click that button and it plots the dots just like we saw on that last one. If I want to have that center line drawn, I can go to add chart elements. Here's trend line. And I can go down to linear or exponential. And it draws my line in a way that is calculated inside the computer that reduces the distance between the dots and the line. And so that line is my prediction. All that line is a result of that mathematical equation. The mathematical equation in my model translates into that line. Now, there are what we call transformations. A transformation in, just to double check, your screen says transformations now? Does that say transformations? Is that what you see on your screen?
Yes, transformations, reciprocal, exponential. Yes.
All right. So wanted to make sure. So what a transformation does, it transforms a concept into a mathematical number so that the computer can read it, understand it, and calculate it within that equation. And so there's different types of transformations. All it does, it's translating distance or condition into a mathematical number so that I can look at that scatter graph and I can reduce the distance between the dots and the line. So a reciprocal transformation is something where you have the result of dividing a number into one. And it's very useful for distance variables. So if I have a property that's right next to a river, that property along the river is very valuable. And then as it gets farther away from that river, the value drops off. Or if I'm, got mass transportation and I've got a mass transportation hub where I can, get on and off the mass transportation that you have, then being right close to that is very valuable, but the value drops off real quickly the farther you get away from that, from the subway. And so you can use a reciprocal to do that. So a reciprocal is the reciprocal of 4 is 1 divided by 4, which would be 0.25. The reciprocal of 5 would be 1 divided by 5. So the reciprocal is 1 divided by whatever number that is. And so if I've got 4 miles away, or if I've got 2 miles away, I can use the reciprocal and I multiply this factor times my land value based on how close it is to, say, the subway entrance. An exponential transformation could be either a positive or a negative number. What an exponent is, it's how many times you multiply a number by itself. So 2 to the second power is 2 times 2. 2 to the fifth power is 2 times 2 times 2 times 2 times 2 is 32. Notice there's 5 2's. 2 to the third power is 2 times 2 times 2 is 8. So that's useful for capturing nonlinear relationships. Now, in that last scatter graph that we looked at, it had a straight line. But what if my dots are configured in a way that when I draw that line, it's curved? Okay, so I can use an exponent. I can say x to the third power, and I would get something like this. If I have x to the 1.2 power, that line moves and is shaped differently. If I've got x to the x to the 0.70 power, the line would form like that. If I got x to the 0.4 power, it goes like that. So looking at my dots and where they are, if I get that line drawn in the center of the dots to reduce the distance between the line and the dots, and my line is curved, I can use a exponent to fit that line better within the dots. Otherwise, I could use a straight line. Well, I could use negative exponents too. So negative exponents would look something like this, where if it's x to the minus 2.0 power, I get a line like that, x to the minus 0.40, minus 0.70, minus 0.80. So depending on where my lines are, I can calculate this exponent to have my computer draw the line in a way that reduces the sum of the errors. Actually, it's the sum of the squared errors, because it doesn't matter if you miss it by 2 on the upside or 2 on the downside, you missed it by 2. So -2 or +2, you get around that by squaring them. So 2 times 2 is 4, -2 times -2 is 4. You missed it by 4 either way. So if you square the errors, you're trying to reduce the error between the line and the dot. And depending on the configuration of the dots, well, that's when you can use exponents to transform this concept into a number that I can plug into my equation. If the exponent is greater than 1, the differences are expanded. If the exponent is less than 1, the differences are contracted. If it equals 1, the differences are unchanged. If my exponent is 0, the result is 1. And if the exponent is less than 0, the direction is reversed. I can also use logarithmic transformations. A logarithmic transformation is an exponent to which a given base must be raised to obtain a specific number. So that's useful in capturing what we call the economies of scale. If you've got a land value, if you've got a small lot, it might be $5 a square foot, for a 1,000 square foot lot. But if it's a 50,000 square foot lot, it's probably not $5 a square foot anymore. Maybe it's $2. And if it's, 5 acres, maybe it's $1 a square foot. So you can capture economies of scale by logarithmic transformations. So what is a logarithm? 2 would be the exponent that 5 must be raised to get 25. So if I want 25 and I've got 5 as my base, I can raise it to the second power. 3 is the exponent that 2 must be raised to get 8. So a lot of this is just a review of math and something, like I said, it takes 30 hours to go through this step by step, and I'm giving you a quick overview. However, I just want to give you the idea of what an exponent or a logarithm does. Logarithms are for economies of scale. Exponents are for curved lines. Reciprocals are for distances to a central value point that drops off quickly. I got multiplicative transformations where I might multiply one variable by another. So I might have a size related variable by a quality related variable. So if I've got linear feet of cabinet, size times quality, I can smooth out my model by multiplying those two together, how many linear feet of cabinet plus some kind of factor for the quality, average, good, or fair, and use that and plug it into my model. A quotient is the result, a quotient transformation is the result of dividing one variable by another. So sometimes if you have a property and you're looking at how much value does the square foot of living area contribute, it may contribute an amount to the total value, but then the number of rooms might also contribute a value number to the total. And sometimes that there's what they call collinearity, where you've got two different variables that are influencing the model in too strong of a way. Because if you got a larger house, you're probably going to have more rooms. So if you divide the square foot living area by the number of rooms and then use that as my term, then that prevents that model from being over influenced by a large building size. Racial studies is something that we kind of hinted at before, where I took my assessment and my sale and compare them. Racial studies are an important tool for mass appraisal modeling. You can do a racial study to measure your model performance before you do a revaluation. You can use racial studies to measure model performance during a revaluation. You can use racial studies to measure model performance after a revaluation. What is a ratio? Well, we call it an AS ratio. It's the assessment sale ratio. So it's calculated by dividing the assessed value by the valid sale price. Not all sales are used. Some sales are invalid because it's a sale between a related party or there's some other unusual circumstance. However, the valid sales, what if my assessment was at 90,000 and it sold for 100,000, I would divide the assessment by the sale price and I get 0.90. That tells me that my assessment is a little bit low. It's about 10% too low. What if my assessment was 100,000 and it sold for 100,000? 100,000 divided by 100,000 is 1.0. That means my assessment's right on the money. What if my assessment was $110,000 and it sold for 100,000? Well, that ratio is 1.10, which means I'm about 10% too high. And so I can look at these ratios that I get from comparing my assessments that I have already to this actual sales, my new sales, and I can get an idea, am I too low? Am I too high? Am I doing okay? So I would look at my assessments and my sale prices, and I simply divide each assessment by the sale price, and I get my ratio. And then once I have my ratio, I can do statistical testing on there in order to find out how my mathematical model is performing. I use what we call measures of central tendency, measures of dispersion, and goodness of fit measures. For measures of central tendency, we have what's called the mean and the median and the weighted mean. What the mean is, it's simply the arithmetic average. And so if I calculate my AS ratios, again, I divide my assessment by my sale price to get the AS ratio. I can take those ratios, add them up. How many do I have? 1, 2, 3, 4, 5. I add them up, I get 495. I divide by 5. My mean ratio is 0.99. If I took the same ratios and I put them in order from lowest to highest, that's called an array. And if I take the middle one, the middle number is my median. That is another measure of central tendency. And I've also got the weighted mean, where again, if I have my assessments and sale prices, now I do things a little different. I take all my assessments and I add them up and I get 1,374,000. And I take all my sale prices, add those up, and I got 1,392,000. I divide the 1,374,000 by the 1,392,000, and I get a weighted mean of 0.987. If I'm close to 1.0, that's telling me I'm pretty good. Right? So those are some ways to tell if my assessment level is too high or too low. Typically, we recommend using the median because that's less affected when you've got what we call outliers. If you got some numbers that are way off, if you're using the median, it'll tend to perform better. Measures of dispersion, you've got the range, standard deviation, coefficient of variation, which we call the COV, and the COD, coefficient of dispersion. So the range, you simply take the lowest and the highest, got them in order, right? They're in order from lowest to highest, and you take the highest and subtract the lowest, and you've got a range of 0.14. For a standard deviation, that's something that's used in a lot of disciplines like science and other math and finances. It's a measure of the variation, the dispersion in any set of values. So we get that by subtracting the mean from each value. So say if I got the assessment ratios, I take whatever the mean was, I subtract that from each ratio in my list, and I get a number. I take that number and I square it, because I don't care if it's plus or minus. I'm squaring it. I sum the square differences. I divide by the sample size less 1 to obtain what we call the variance. So if I've got 10 numbers, I divide by 10 minus 1, or 9. Once I got the variance, I calculate the square root of the variance, and that gives me my standard deviation. That says, what is my average deviation from my mean? The coefficient of variation is simply the standard deviation in percentage terms, where I'm taking that standard deviation, dividing it by the mean, and multiplying it by 100. The coefficient of dispersion is the most widely used measure of uniformity. It represents the average absolute percent difference from the median. the lower the COD is, the better it is as far as being uniform. It's the absolute deviation. So from the median, I'm taking the median now of my ratios. So if I have, let's see, where was that? Looks like here, my median ratio is 99. So I would take 0.91 minus 99, 0.96 minus 0.99, 0.99 minus 0.99, 1.04 minus 0.99, 1.05 minus 0.199. I subtract the median from each ratio, and I take the absolute value of the difference. So in other words, I don't care if it's a plus or minus sign. I just take the absolute value, and then I want the average absolute value. So I add up all the absolute differences, all those numbers. I divide by the sum of the sample size, divide by the median, and multiply it by 100, and that gives me my COD, and that's a widely used method of dispersion. So if my median is here, am I missing it by this much? Am I missing it by that much? So how wide is the range of error? How much dispersion do I have? The less dispersion, the better my model is performing. And IAAO has standards as to what's an acceptable COD range. When I'm doing modeling and I'm adding variables, I've got size, I got condition. I can tell what variables are the most important by something called the t-value. So the higher the t-value, the more important that variable is. So I put my variables in one at a time. That's called stepwise regression. And I start out with 2 variables, then maybe I add another one, I add a third, a fourth, a fifth. I can keep adding variables into my equation, and I look at 2 tools called the R-squared and the standard error of the estimate. The R-squared goes from 0 to 1, and the closer it is to 1, the better it is. So I might have only 2 terms in my model, and my R-squared might be 0.4. I add another term, and it goes to 0.6. I add another term, for garage, and it goes to 0.7. I add air conditioning, goes to 0.8. I add a new roof, and it doesn't go anywhere. So some variables are more important than others, and that R-squared, the closer it gets to 1, is telling me my model is performing better and I've got the right number of terms in it. The standard error of estimate is basically just the standard deviation for the regression model. R-squared, by definition, is the percentage of variation in sale prices that are explained by the model. The higher, the better. The highest value is 1. Standard error of the estimate is the standard deviation of the regression errors. Again, the stepwise regression, you add the variables to the model one by one according to the next highest t-value. T-value is a separate calculation, and when you've got statistical software, it'll tell you what the t-values are. The statistical software can also help you place that line in between the dots. It can give you what the exponent should be. It can tell you the t-values, and the variables with t-values that are above 2.0 are the most significant. So in summary, model building is part mathematical, but it also is part art that comes with experience. And it's kind of a whirlwind hour that we just had. I'm guessing nobody was bored. When it goes fast, you get a lot of material. Time goes fast, but that just gives you a sample of mathematical modeling for mass appraisal. And if you want more information, IAAO has a workshop 354 called Multiple Regression Analysis. They've got a workshop called 311, which is Real Property Modeling Concepts, and we go into it with a lot more detail. Meanwhile, thank you, and here's more information about me. If you want contact information, simply QR code, give you my information. Looking at the chat, PowerPoint will be sent later. you've got my permission to do that. Anybody have any questions, or Sopon, I'll put it in your hands if you got questions or comments, or if you want to orchestrate anybody's questions and direct them to me. It's whatever you would like, sir.
Yes, sir. So thank you very much for your contribution for us. Our colleagues asked for your presentation. Maybe you could kindly send to me, sir, so that I can distribute them to our participants here. Maybe you can kindly email me or send me via Facebook Messenger or anywhere, anyhow, so that I can
I'll tell that to you, and as they watch the video on YouTube, I'm sure that as they watch it a second time, that they'll pick up more. I know I went kind of fast, but I wanted to try to give you a quick overview. And you know, if it was too fast, I apologize, but I'm available if you've got questions, or you can watch the repeat, and I will send you the PowerPoint.
Thank you, sir. Yeah, so that is the thing about the mass appraisal. Normally, so far as we learned from Mr. Winter, is that when we want to do valuation, normally we do one by one, say a house by another house or something. But because of there are some similar characteristics, and there are many variables, values that maybe we can share, say maybe close to the main road or not, the size. So these are all the information that we use to build the model. You can see that easily that the value of properties is equal to the size of land multiplied by the value of land plus the size of the house multiplied by the cost of construction of the house. So this is the simple equation or simple formula. However, there may be some other factors, like as Mr. Winter said, maybe it is a corner lot, or it is a very a lot that close to the river or canal. That should be good, except that canal may be polluted canal, maybe it may not be good. So these are all the factors involved. So we have to put this figure in so that we can estimate the value more closely. And the relationship of price to of the value to the factors may be not a straight line relationship, not a very straight line. Like when we increase our salary, say the salary of Mr. Winters, say 30 years ago, maybe say 1, and the salary of Mr. Winter today, 30 years later, maybe 6. So it may be 6 times more, but it is not a straight line relationship. The relationship may be like a curve. Maybe the increase per year may be the same, say 10% per year, 10% per year, but the increase will be like a curve line. Increase 10% every year, but it is not a straight line, because straight line may be not a realistic relationship or something. Or maybe sometimes, as we learned from Mr. Winter, that there may be some addition. There may be here there is a garage, another one no garage, or maybe depreciation. As we know, depreciation normally in Thailand, sir, we have a straight line depreciation, say 1 or 2% per annum. However, in realistic, at the beginning there may be very little depreciation, but for time go on, maybe more depreciation. Something like I myself, maybe when I met Mr. Winter, formally, maybe less depreciation may not be observed every year when we went to the IAL conference, but for 10 or more than 10 years later, maybe we can observe more depreciation or when time go on. So this is what happens. So this is the as Mr. Winter said that maybe the relationship may be something like a logarithm or maybe something like a exponential factors that we have to test, and this is also available in Excel like Mr. Winter already show us. So if we like to learn something more about this, we plan to invite Mr. Winter to come to our region here so that maybe we can go to different countries to have some lecture, and also he can also have some retreat in our Southeast Asia region as well, or even go to India, very big countries indeed. So this is what happened. And so far, any questions so far? Any comments or anything? That should be no. We have over a moment ago 50 or 60 participants, but no worry. We have registered around 90 participants, but some of them maybe not yet got up, or maybe on the way. So I will send the YouTube back to you so that you can study later. And if you have any thing, you can contact Mr. Scott Winter later on to have some question or something directly to Mr. Winter yourself. And this is the you may highly scan. This is the scan for more information on this. So, Mr. Winter, do you have any last words to say to our participants, sir?
I'm honored again that you had me to present. In summary, realize in that mathematical equation, you've got all your different terms, and each term can be different depending on that variable. So you can have maybe adding 5,000 or not for air conditioning. You can have a variable for depreciation, that's an exponent. You can have a variable for distance to the canal, that's a reciprocal, and you just connect all those terms together with adding or multiplying or dividing or subtracting, and you get a string of mathematical equation. That mathematical equation produces that line that reduces the error between, or the distance between each dot in the line. And so that's the general concept. There's a lot to it, and there's a lot to learn about it, and it's fun once you get into it. I find it's like driving a car, that I can read about driving a car, but I'm not as good at driving the car until I actually get behind the wheel and drive it. And it's the same thing with modeling. You can study and learn, but when you start doing it and playing around with it, then that's when you really grasp and learn it well. But thank you, everybody, for your time and attention. Thank you, Sopon. It's so good to connect with you again. And, may you have a great rest of the day. And it sounds strange, but pretty soon I'll just be going to bed.
Thank you, sir. So, good night to you. All the best to you. God bless you. Sweet dreams. Thank you very much. And thank you, everybody, for joining us. See you again. Bye-bye.
Okay. Very good. Bye-bye.
Thank you. Bye-bye.